Hello students, let's do set concepts, exercise 6C. Before we begin the exercise, children, let's learn some more set concepts. And the first one here is a subset. What is a subset? If each element of set A is also present in set B, that is, you have a set A and you have set B, and all the elements of this set are there in set B, then you say that set A is a subset of set B. Let's take an example. Now look at this. Set A has elements 1, 2 and 3 and set B has elements 0, 1, 2, 3 and 4. As you can see, all the elements of set A are there in set B. So in this case, you say that set A is a subset of set B. And how do we write that? With the help of a symbol, this is how we write. So how do we read this? Set A is a subset of set B. Now what do we call B in that case? In that case, we call B a superset. When set A is a subset of set B, then B is called the superset of set A. And how do we write it? We write it like this. So what does this mean? That B is a superset of set A. Now, there are some points to keep in mind. Every set is a subset of itself. Remember what subsets are? So, every set is a subset of itself. An empty set is a subset of every set. So, let's take an example. Now, if we have A is equal to 2 and 3, then what are all the subsets of this set? So let's write the subsets of set A. So first you have to put an empty set. Okay. Remember we just said empty set is a subset of every set. So whenever you're asked to write subsets, first thing we do is put an empty set. Then we take each element separately. Okay. So here we will put a comma here and then I'm going to put another set with only one element. Okay, because we have 2 there. Then I'm going to put the next element, which is 3. Okay, so what do I have? I have an empty set, then I have 2, then I have 3. Then look at this point which says every set is a subset of itself. That means I can put this whole set. So let me put a comma and put that whole set, that is 2 and 3. So now can you see these are all the subsets of this example set A. So we have an empty set. Start always with an empty set. Then take down each element separately and write the whole set itself because every set is a subset of itself. So these are the subsets of set A. Now we have something called the proper subset. Now we just wrote all the subsets of set A, isn't it? All the subsets of a set other than the set itself are called proper subsets. Okay, so you write all the subsets just like we wrote now. We wrote the empty set, we wrote the elements inside, and then we wrote the set itself. But in this case, you don't write the set itself. So that set you leave out and write all the other sets, and that is called the proper subset. So here, if A is a proper subset of B, then we write it as this symbol. A is a proper subset. Remember, there's no line underneath. If a line is there underneath, we say A is a subset of B. If there is no line underneath, we say it's a proper subset. That means we're going to leave out that set itself. So here, if we take an example, A is equal to 2 and 3, then what will be the proper subsets? Like I said, start with an empty set, then write the first element, write the second element. Now, if we are writing subsets, we write this whole set also, isn't it? Because every set is a subset of itself. But when you're writing a proper subset, you must not write the set itself. So the proper subsets of set A are these sets. Now, we are going to find out about the number of subsets and the number of proper subsets of a given set. Now, it's going to be difficult to write out every set and count. Now, there is a way to find out without writing every set how many subsets a set can have and how many proper subsets a set can have. So, there is a formula for it. Now, if a set has n elements in it, if the number of elements are n, if we give it n, the number, then the number of subsets will always be 2 raised to the power of n. We'll do this with an example. It's going to be easy for you to understand. So subsets will be 2 raised to the power of n. The number of proper subsets will be 2 raised to the power of n minus 1. Why minus 1? Look at this, a proper subset. We will not write the set itself. So 2n is subsets. Proper subsets is 2n minus that 1. And what is that 1? That 1 is the set itself. So again, let's take an example and do. So here we have a is equal to 2 and 3. So number of elements is 2. Okay, so number of elements here we said let it be n. So that is 2. So that means, what do we mean by that? We say that n is equal to 2. The number of elements is 2. Now we are going to find the number of subsets. The formula will be 2 raised to the power of n, as we can see here, 2 raised to the power of n. So that is 2 raised to the power of n is 2. So that is 2 into 2. 2 2s are 4. That means the number of subsets, we have found the number of subsets without actually writing out the subsets, that it's going to be 4. So we know that the number of sets will be 4. Now to find the number of proper subsets is 2n minus 1. We just found out that 2n is 4. 4 minus 1 is 3. That means the number of proper subsets will be 3. Okay, so I hope you have understood this. So if a set has n elements in it, that is, it has 2 elements, the number of subsets will be 2 raised to the power of n. Suppose there were 3 elements, it will still be 2 raised to the power of n. And n will be 3. Here we found out n to be 3. So the number of subsets will be 2 raised to the power of n, we found out. Number of proper subsets will be 2 raised to the power of n minus 1. Why are we minusing 1? Because we are going to remove the set itself. In the subsets, the set itself will be there. But in the proper subsets, that will not be there. So you just have to remove that, remove 1. Okay, so that is how we find out. So we will use all this when we do our exercise. Now there is one more set, and this is called the universal set, and this is the symbol. This is a symbol for a universal set. So what is a universal set? Any set which contains all elements of the various sets given is called a universal set. Suppose you have 3 sets. All these elements together will be present in one set, and that set is called the universal set. For an example, here we have set A with 2 and 3. Now the elements are 2 and 3. Set B is 3, 4, 5. Set C is 2, 3, 4, 5, 6, 7. Now what is a universal set? A universal set will have all these elements in it. So let's write that. So this is a symbol for a universal set, or you can even put this symbol. So here 2, 3, 4, 5, 6, 7. This is a universal set which contains all these elements. Let's see. Now set A has 2 and 3. Is it there in the universal set? Yes, 2 and 3. Set B has 3, 4, 5. Is it there in the universal set? 3, 4, 5. Yes, it's there. Now set C has 2, 3, 4, 5, 6, 7. Is it there? Yes, 2, 3, 4, 5, 6, 7. So a universal set is the set which contains all the elements of the set given sets. There will be some sets given to us, isn't it? All those elements will be present in one set, and that one set is called the universal set. Now I can also put this in a different way. I can also write a universal set like this, which says the numbers are from 1 up to 10. Now, does it make sense? 2 and 3, does it come here? Yes. 3, 4 and 5, does it come here? Yes, it comes here. This also comes here. So I can put it this way also. I can say my universal set has all these elements from 1 to 10. I can also say that universal set is set n. What is set n? N is natural numbers. And all these are natural numbers. They will all be part of the universal set. Now, sets A, B and C are subsets of the universal set. So set A is a subset of the universal set. Similarly, set B and set C are also subsets of the universal set. Now here we can say a universal set is a subset of itself. Isn't it? When we learn subsets, what did we say? The set itself can be a subset of itself. Here That's what we mean when we say the universal set is a subset of itself. Now let's begin our exercise 6C, which is found on page number 88. Based on all that we learned, let's fill in the blanks. So question 1. If each element of set P is also an element of set Q, then P is said to be a subset. So let's write that. It is said to be a subset of Q. Okay. And what is Q called? Q is then called the superset. Q is called the superset of P. Every set is a subset of itself. Question 3. The empty set is a dash of every set. The empty set is a subset of every set. Question 4. If A is a proper subset of B, then the cardinal number of A will be dash than the cardinal number of B. Now remember what a subset is. A subset will have all the elements. It will have the empty set. It will also have the set itself. Whereas what is a proper subset? A proper subset will have everything just like a subset except for the set itself. Except for the set itself. So here the question is, now A is a proper subset of B. That means there will be one set less in set A, isn't it? So the cardinal number of A will be less than the cardinal number of B. One less than the cardinal number of B. Cardinal number of A will be less than the cardinal number of B. Question 2. If A is equal to 5, 7, 8, 9, these are the elements of set A, then which of the following are subsets of A? Remember how we write subsets? Subsets will be all the elements of these sets, plus it will be an empty set, and it will also be a set itself. Now look at the first one. B is equal to 5 and 8. So the elements 5 and 8 are there in set A, isn't it? That means B is a subset of set A. So the first one is correct. Next is C is equal to 0. So is 0 there in set A? It's not there. That means C is not a subset of set A. Second one, D is equal to 7, 9 and 10. 7, 9 but 10 is not there. So that means D is not a subset of set A. Now this is how we write not a subset. We write subset symbol and put a cross. So not a subset. Similarly here also D is not a subset of set A. Question 4. E is an empty set. Remember, an empty set is always the subset of every set. So here you can say E is a subset of set A. Question 5. F is equal to 8, 7, 9 and 5. Let's see. 8, 7, 9 and 5. It's a set itself. And this also we have learned, the set itself is a subset of every set. So here we can say set F is a subset of set A. So what is the final answer? 1, 4 and 5 are subsets of set A. That is 1, 4 and 5. They are all subsets of set A. Question 3. If P is equal to 2, 3, 4, 5, then which of the following are proper subsets of P? Proper subsets means all subsets leaving out the set itself. So look at the first question. A is equal to 3 and 4. Do we have them in 3 and 4? Yes. So A is one answer. So we have A here. So A is a proper subset of set P. Let's look at the second one. B is an empty set. Yes, an empty set is also a proper subset of set P. Okay, so let's take that also. Now look at the next one. C, the elements are 23 and 45. We don't have that there. We don't have 23 and 45. So the third one is not a proper subset. Fourth one, D is equal to 6, 5 and 4. Now we don't have 6 but we have 5 and 4. So this is not a proper subset of set P. Next one, E is equal to 0. Now we don't have 0 there. So E is also not a proper subset. So what are the proper subsets of set P? Only questions 1 and 2. So A and B, that is set A and set B, are the proper subsets of set P. Question 4. Here we've been given 1, 2, 3, 4, 5 sets. Set A, set B, set C, set D and set E. And we've been told what the elements are. Now we have to say which of these are true or false. So let's see the elements. Set A, even numbers less than 12. So let's write down all the even numbers less than 12. So even numbers less than 12. 2, 4, 6, 8 and 10. These are the even numbers less than 12. Now we have set B, C, D and E. Now let's see which of these is true. First one, B is a proper subset of A. So B is 2 and 4. Is it there? Yes. So B is a proper subset of A. That statement is true. First one is true. Second one, C is a subset of A. Now C is 1, 2 and 3. Do all the elements of C belong to A? No. Here we have 1, 2 and 3. We don't have 1 and 3. That means C is not a subset of set A. So this statement is false. Next one, it says D is a proper set of C. So what is D? D is 2 and 6. And here let's see here, proper set of C. And C is 1, 2 and 3. D is 2 and 6 and C is 1, 2 and 3. And as you can see, it's not a proper set. So here we can write false. So the statement is false. Question 4. D is not a subset of A. D is not a proper subset of A. So we have D here and A here. What are the elements of D? 2 and 6, which is there in A. So this is actually a proper subset of A, isn't it? But what does the statement say? It says that D is not a proper subset of A. The statement is false. Next one. E is a superset of B. Now where we have E here, E has 4 and it says E is a superset of B. That means all the elements of B should have been there in E, but it's not there. So this statement is false. E is not a superset of B. False statement. Next one, A is a superset of B. Now let's see that. So this is A and let's see B, 2 and 4. All the elements of B are there. That means A is a superset of B. Then what does it say? B is a superset of E. Now B has 2 and 4 and E has 4. So definitely B is a superset of E because E is a subset of B. So this statement is true. Question 5. Given A is equal to AC, B is equal to P, Q and R and C is equal to set of digits used to form the number 1351, 1351. Now we have to write all the subsets of sets A, B and C. So let's begin. So set A is A and C. There are two elements. Now we have to form the subsets. So first begin with the empty set. So we have an empty set. Then let's take only one letter A. Then let's take the other letter C. Then we have the set itself A and C. So these are the subsets of set A. B. B is PQR. Now the subsets of PQR are again first the empty set. Then take each letter P. Then we have Q. Then we have R. Now take two letters at a time. So we'll take P and Q. P and Q. Then let's take P and R. Now what else can we take? We can take Q and R. Q and R. And now we can take the whole set. P, Q and R. So these are all the subsets of set B. Now set C are the set of digits used to form the number 1351. That means what is this set? This set will be 1, 3, 5 and 1. All the digits used to form that. Remember, we should not repeat elements. So here we have 1 which we will not repeat. So what are the elements of set C? 1, 3 and 5. Now the subsets are, again start with an empty set. Then let's take the first one, that is 1. Then let's take the next element 3. Next element 5. Then take 2 at a time now. 1 and 3. Then 1 and 5. And 3 and 5. Now take the whole set itself, that is 1, 3 and 5. So these are all the subsets of sets A, B and C. Question 6. In this we have 4 questions. First one. If set A is equal to P, Q, R, then the number of subsets of A. Remember, we learnt about number of subsets and number of proper subsets. So to find the number of subsets, we say 2 to the power of n. And to find the number of proper subsets, we say 2 to the power of n minus 1. So we have to use this formula. This is to find the number of subsets. And this is to find the number of proper subsets. Now what does n stand for here? N stands for the number of elements in each set. So look at the first one. How many elements are there? There are 3. That means n is equal to 3. There are 3 elements. So n is equal to 3. Then the number of subsets, we will use the formula 2 to the power of n, which is 2 to the power of, and what is n? N is 3. 2 to the power of 3 means 2 into 2 into 2. You multiply 2 3 times. 2 2s are 4, 4 2s are 8. So what is our answer? 8. The number of subsets will be 8. We don't have to write down all the subsets and then count. You can use the formula and find the answer. Next question. If B is equal to 5, 4, 6 and 8, then the number of proper subsets. You know it's going to take some time to write down all these subsets and then count. Instead, we can use the formula. The formula to find the number of proper subsets is 2n minus 1. So let's use that formula 2n minus 1, 2 to the power of n minus 1. And what is n? N is the number of elements. So here how much is n? 4. The number of elements is 4. So this will be 2 to the power of 4 minus 1. Now how much is 2 to the power of 4? You multiply 2 4 times. 1, 2, 3 and 4. 2 2s are 4, 4 2s are 8, 8 2s are 16. So this will be 16, which is 2 to the power of 4 minus 1. So the answer is 15. 16 minus 1 is 15. So the number of proper subsets of B is 15. Next one, C is equal to 0. This one element. So number of subsets. The formula is 2 to the power of n. To find the number of subsets, 2 to the power of n. And n is the number of elements. The number of elements is 1 here. So n is equal to 1. So this will be 2 to the power of 1, which is 2 itself. So the answer here is 2. Next one. Now this is given in the set builder form. Let's read it. X is such that x belongs to natural numbers and x is less than 3. Natural numbers begin from 1, isn't it? And here it says less than 3. So we have only 1 and 2. So this is M. Set M is equal to 1 and 2. Now here they are saying, so now that M has so many elements, find out how many proper subsets M has. So to find the proper subsets, what is the formula? 2n to the power of n minus 1. And n is how much we found out here? N is, there are 2 elements, n is 2. So 2 to the power of 2 minus 1. 2 to the power of 2 means 2 into 2, which is 4. 4 minus 1 is 3. So what is the answer here? M has 3 proper subsets. Question 7. For the universal set with all these elements, remember a universal set is a set which contains elements of all the given sets. So from this we have to find the subsets of A, B, C and D such that A is equal to even numbers. Let's follow that and do. So A is equal to even numbers. So we're going to pick out all the even numbers from the universal set. So what are the even numbers here? 4, 6, 8, 10 and 12. So let's write all the even numbers. So A will be 4, 6, 8, 10 and 12. So we have picked all the even numbers from the universal set for set A. Set B is odd numbers greater than 8. So let's see. So here we have 8 here. Now let's pick out all the odd numbers greater than 8, 9, 11 and 13. So let's write that down. So odd numbers greater than 8, set B is equal to 9, 11 and 13. Set C is prime numbers. So let's look at all the prime numbers here. 5, 7, 11 and 13. These are the prime numbers. So let's write that down. So set C will be prime numbers that we have underlined. 5, 7, 11 and 13. These are the prime numbers and these are the elements of set C. Now question 4, D is even numbers less than 10. So where is 10? 10 is here. So let's take all the even numbers less than 10. 8, 6 and 4. So 4, 6 and 8. Let's write down the answer. So set D is equal to even numbers less than 10 which belongs to the universal set. So that is 4, 6 and 8. So these are our answers and these are all the subsets which we got from the universal set which contains all the elements of all these sets. So with this children we come to the end of this exercise. Thank you children.